Well, how's it going, peeps? I've been subbed to this guy for a while, and he just posted this video I found pretty interesting. Hooks up some high voltage here, some static electricity to this. It looks like just some dead grass, like a plant that has died. Pretty cool. He's got this sitting in a pot with, looks like he's got the, I'm not sure if this is probably grounded here. Maybe this isn't, maybe this is ground, but so he's basically got it setting up on a capacitance here and, building up a static field around it. Pretty cool. Okay, he's got the plate here I'm trying to figure out, but he'll illuminate this light with it. Pretty cool. Wow. So it's like this, once you get the charge flowing through this material, it gives it the radial expression, which is, if you look at this plant with this ion wind, it's no different than the sun's corona. I mean, that's what's so wild about it. It's no different than any flower expressing itself in the sunshine. And so what I did is I made a comment down in here. I got to give this guy kudos. He does some pretty interesting experiments. But, oh, it's cool, man. He made a comment. Thanks, dude. Thanks for the comment. I know something about the static field interaction with plants and other biology, but I need to try. Cool, man. Yeah, that's awesome, dude. Yeah. But this guy's got some interesting stuff. He does some really interesting, like experiments underwater and changes the color and the expression of it. Just really neat. But I really appreciate guys like this out here, man. Anybody that gets online and tries to educate and teach people stuff, valuable stuff. And quite frankly, when you start messing around with electricity, you're messing around with the most powerful thing ever. So anybody can do experiment. Anybody can mess around with this stuff. It's not that scary. You got to be careful with it. But when you start messing around with this stuff, you mess around with, I would say, the creation. I mean, you mess around with it, with everything. I mean, it is everything. Generates the magnetic field, creates life, structures minerals, animates everything. So, but I mean, let me read this. A great experiment to set up would be to germinate a plant while the SEF is present. After the plant has started off, terminate the SEF, see how the plant is structured differently. So, this is just dead material, but what would be interesting is to, you see these Ebner effects with the seeds, placing them between the capacitance plates, but you could do the same literally with the plant. And I've seen other experiments done with people just grounding out their plant, like with copper. If you've got indoor plants, you can ground out your plant, and some of them actually kind of structure themselves differently. But what would be interesting is, just put a low voltage on this, or because I think the Ebner effect requires 716 volts per centimeter, and I think you put it between like a centimeter gap. Any kind of eggs or seeds or whatever, and it will change the phenotype expression in it. It will. I don't know if I even mentioned that. I was going to mention that when I forgot to. No, I did. Static fields can alter phenotype expression in organisms. I mean, it really is. It doesn't change the genotype. I mean, everything's kind of structured with its basal, bone material, things to keep it rigid, eye receptors, ear receptors, some kind of way of receiving information from your environment. They can contact the surface of your organism essentially, but yeah, it's pretty wild. If he had a small voltage with just and even germinated a few seeds in here, there's a lot of interesting stuff that can come out of it. And I'm doing this video because it's really an unknown deal. There's not a lot of information on it. I mean, there's some halfway decent videos and they're older, but even if I were to Google Ebner effect, there's not much on it. And what this Ebner effect clearly shows is that evolution, phenotype expression, even amongst, I mean, this is the thing, any variety of organism can be altered with just changing the field within its germination time, if that made sense. So you can germinate the seeds within a static field, but then take that static field away. These plants have now the proteins or the DNAs, the magnetic resonance, whatever structures the proteins, what gets them to structure and grow this thing in the electric field. Now they will grow according to what was set on them. And it's just very interesting, the concepts. I did a chat yesterday and it went long. I don't think I had nobody joined. I had one guy make a comment, but this stuff is pretty profound. And because when you start thinking outside the box and you start thinking about fundamental theories on evolution or even finding plant species out in rocks and stuff, if you've got one generational change in an organism and it looks like a million-year difference, I mean, this is what's so interesting about this too, is that this interaction with Mars and the polar configuration, even if Venus is swooping around, which I mean, it's written about in archetypal histories. You know, you got this Venus as a comet at one point. You would get a lot of biochemistry. You would get even times where the static field on the Earth would be different, and especially in that polar alignment with Mars, you would have this crazy mountain of water built up in the north for a time. The tension in that water would change any kind of organism, especially aquatic, but even if you're on land, any seeds, smaller organisms, their chromosomal makeup can be tugged on. And that's what goes down. And what's even more interesting about it too is you can think about this. If you've got Neanderthal, it throws traditional theories away it throws traditional ideas of differentiation of species, because if you've got an electric field change on the planet, your phenotype expressions can be very crazy amounts. You know what I mean? This is what's so cool about it. You got Japanese people, right? You got Chinese people. Well, we all have eyes, ears, and stuff, but they do look different, right? Well, their phenos, when they were spawned, they literally had a different tension on their organisms at that time. It's just amazing. And, you know, if you're living in certain regions with different electric fields, well, now you're kind of growing in, you're set in that motion, right? So now you look like a Japanese person or whatever. But fundamentally, we all have the same kind of genotype. Anyway, I hope I'm making sense here. So you get this idea of an ancient fern. Well, if you've got these leaves, this is one generation, static electric field fern. What they did is they just took seeds and they germinated in a static electric field, put the tension on those structuring magnetic DNA that makes the plant grow, and now it'll grow different. It's just unbelievable. It'll do it to bacteria. It does it to everything. I mean, think about that. So static electric fields can fundamentally alter bacteria, and you know you can get just a basically mutation created from that. You know what's even cooler? I mean, obviously the structuring spheres, but how they line up on a dipole. Fundamentally, you know, everything you've even got the branching, but there's always the main channel. It's just fundamentally starts taking over in these shapes. It's this isolation of charge and the ability to hook up and create these dipoles along channels. I mean, this is how everything really works when you think about it. So this process will take the GMO out of any food. So if it's been genetically altered, you can revert it back to its genetics to a stronger electric field. That's all it is. Once again, SEF is static electric field. I didn't mention that already. Now this is just fascinating, people. So what they did is they took normal trout eggs from harvest and they started doing survival rates on them, right? So they just took normal trout eggs germinated without the static electric field. They only had half of these eggs survive. Okay? Now, with the static electric field, less eggs died. So they almost had, look at the rate of the survival on that. If you're any kind of farmer and you want as much, material from your germination, right? I mean, well, why wouldn't you revert to this? This is what's interesting too, is that this is one generational change in this trout, and it fundamentally, just by placing it in the static electric field, changed its shape. Now, when you start thinking about that, right, you start changing the shapes. If you've got a planetary static electric field change, a tugging on it, just a stronger tie. If the moon were to actually change its orbit for a time, I mean, because that's the thing, the moon can actually get closer, and if you've got a stronger tie and it's moving around the planet, you can start kind of changing the DNA and planet, the phenotype expressions. That's what's wild about it. So this is the fish without the static electric field. This is with it. This is with the static electric field. Same fish. Once again, they took eggs from this fish, applied a small electric field to this, put it in between two plates, and now you got this fish. And if you were to drain that pond and you had these two fish, right, going down, that's the thing. If you had some kind of static field in an ocean, and now you've got eggs or whatever's floating in it that can get changed fundamentally. You've got this thing floating around in the pond. You got right now you got this thing popping out of that. So when we start thinking about humans and things on land and how fast you can structure and change how they grow in the field, wow. Quite literally, you could have Cro-Magnon man just walking around. You could have hominids walking around, have this fundamental change in the static field go down, and now the eggs and sperm in these things, that they fundamentally change themselves. So now when they mate and these things grow in the new static field, you have an organism that could look like Cro-Magnon man in one generation. So pretty interesting how it fundamentally changes the trout and actually makes the trout better, meatier, hardier. And when you think about it, if you've got this, it's like bodybuilding or something. If you put tension on your muscles, you tend to grow, and you're creating this different field around you. When you think about it, you're artificially creating the different resistance from gravity, right? That's all it is just this dipole tug on your body. You bodybuild, you build up an adaptation to this artificial static field, right? But this is what happens if you fundamentally change it at this level. As the binary fission goes under, this structuring protein is hardened. It's made it stronger. So it makes a hardier fish. Trouts without it, this is what it looks like just in the normal static field of the Earth, and now you got this thing popping out. Pretty tremendous. One generation again, I got to reiterate that. If you're digging for fossils and you're finding different fish and you're claiming this is 1,000,000 years separation, or let's say they say it's 500,000 years or whatever, right? Whatever they want to throw on it. This is one generational change. What are you saying? So this Ebner effect, static electric fields, knowing the electricity of life, evolution's just throws it out the window. Millions and millions of years is thrown out the window. If you're trying to look at organisms in their changed evolution, it's ridiculous. With knowing this, pretty cool stuff. A lot of analysis this guy did. This Guido. So this is normal corn, normal stalks, and then they germinate corn under the SEF, and it just makes a crazy corn. Totally edible, totally safe. It's natural. This is how organisms naturally structure and evolve on the surface of the statically charged ball. So this is not GMO. It's SEF. It's better. And it's just amazing. Anybody can do this. You can do this in your garden out back. Anybody can do this. Anybody can modify organisms. Yeah. And you really don't need but 2 electric plates You germinate your seeds in some auger plates, whatever, dirt. Just germinate them in that field. Makes that, as they grow into it, they think it's in a different earth. But then you take that away and it'll grow like that. It's already set in motion. You don't have to have a crazy static ball out here or whatever. Just fundamentally changes it. They're doing this in some other countries. I mean, what are we doing? You know, I mean, spraying things. This stuff is amazing. What it does to plants. Development of several numerous sprouts. Development of several numerous. And see, I hate it when they misspell words. I think these guys are French or something. I don't know. But sprouts, flowers, and late. You know, it's amazing. I'm not going to read this to you because I'm going to get tongue-tied because it's just amazing. Yeah, pretty cool. Morphological changes, higher germination rate, fertility rate, higher resistance against pet and hard climate conditions, need of less agrochemicals as pesticides, insecticides, and pesticides, less concentrations of animal health products and animal, increased growth, increased maturation. Phenotypic changes due to changed environmental conditions within one generation. Higher electric power differences move the fraction of proteins into the cell. So that's kind of how it's working. It's not actually passing a current through it. It creates an induced static field into the material, which naturally is going to induce magnetism into the material that makes it up. So now you start contorting the protein differently. You start twisting that fundamental structuring thing that starts to make to grow the organism. But it doesn't hurt it. It basically just kind of makes that fundamental code stronger. Like bodybuilding. It's like you're born, you can bodybuild and create an artificial gravity, right? And you get big and you get strong and you get healthy. You're in a different environment. I wonder why they made all these Greek, you know, when you think about all the Greek statues and stuff, right? They're always kind of bodybuilder looking and stuff, but I mean, it makes you think of people, you know, walking around like that. I mean, you had to probably move around more and stuff, but I don't know. It makes you think, right? I mean, you got this. If you got a different feel back in the day, maybe the people just were inherently looking stronger. You know, I don't know. Probably better food and stuff. Epigenetic effect. SEF effects with influence the gene scan. And I cannot read things like this when people do not know how to write things. SEF effects with influence the gene scan. Sorry, it just drives me nuts, and this is why I don't like reading other people's shit. Commutator molecules, proteins. See, what's this? Oh, drives me nuts. Signal compounds. You get the drift. I could probably do a way better presentation. I mean, this stuff is profound, and it's just kind of janked around. So once again, we live on a ball that's a static field generator. It's how we have our atmosphere. It's why we stick to the planet. All the motion and vibration and friction creates electricity. This planet exudes it out into space. Space is dry. And these static fields start creating these, well, it's induced, so they create magnetism. And it's all a skin effect when you think about it, but you do have this centrifugal, centripetal kind of flowing thing going on. You could call it a plasmoid, but like a condensed, slowed down plasmoid. And these things are free to move around static fields. The sun being crazy, charged, plasmasphere illuminated. I mean, it'd be no different than a Van de Graaff generator. If you had a Van de Graaff generator sitting in a room, and instead of just the ones you buy that are 2 or 3 million, get one up to 4 billion volts, and I guarantee you that thing will generate some kind of wild sphere around it. Has to. And because you'd have all these tiny, even within the crystalline lattice of that Van de Graaff generator, you're going to have all these little edges when you look down at the resolution, right? So this thing would just glow like a light bulb in the environment. Anyway. And the environment really determines how these static fields build up, and the shape too. So this is why the universe is built up, and this is why everything's spherical, is because the shape holds on to the charge better, and the dryness of space can actually hold on to that charge. It doesn't dissipate it. So that these spheres we walk around on, these triboelectric, piezoelectric spheres, generate these electric fields around them, obviously, these potentials that exude off of them, no different than a Van de Graaff. You see these experiments, and I don't think there's really a lot of them. Billy Yelverton's the only guy I've seen that actually mentions, the idea that this is what it is. It's acceleration. Little static balloons and stuff, moving material around shows you gravity. That's what it is. You're just a tiny little, iron filled, water filled, magnetism binds into both, static fields bind into everything. But anyway, so what's really cool about this stuff too is that the interchange is due to the SCF content of proteins and minerals. If you think about it, this planet starting off, you've got all this chemistry going down at every level. And now you get this organization of minerals first. This is where animals actually is derived from this word when you think about it. I mean, you can just turn this into animals. But everything on the planet is electrically derived, so all the minerals and stuff start forming these nice complex chains. It's chemistry. But fundamentally, you start getting into bacteria and things that isolate the charge. And if you look at bacteria and viruses, they're spherical shaped. It's pretty wild. So even life, crystals, they start forming these little spherical shapes, and the electricity modulates around them. Some of them will project sharp points off of them to create a different electric gradient around them. Starts getting into this wild boundary layer. I mean, if you think about it, if you could launch rockets out into space, you can only get to a certain height, but if you could back up from the Earth-Moon relationship, right, and just that alone, you could get to a point where you wouldn't see that distance, right? You wouldn't even see that gap as the moon came around. You'd see the moon, right, with a gap, and then it would disappear. Here's the moon again with a gap, but if you back that out, you wouldn't even see that. You'd probably get to the point where you just see just the light, right, with nothing going around it. And so you lose your resolution. It's kind of like looking at a piece of glass that you think's ultimately smooth, but you come down in, and once again you see the jagged canyons and stuff, and where the lattices meet, and how you can cleave it. So, anyway, they did a bunch of experiments on wheat, tomatoes, and it's all in these other countries, the smart ones, I guess. Look at this. Your wheat result was an 18% increase in yield. Once again, if you go back a couple clips here, I mean, they're not using pesticides and stuff. It makes the plant resistant to it. 35% increase in maize. Potatoes had a 17% increase. I mean, and we saw how big those fish got. Once again, the fish, they look different. And it's an epigenetic effect. It doesn't change the fish's structure. It's not growing a head off its tail or anything like that. It just makes the fish stronger. It's like putting a bodybuilder regimen on the seed as it germinates, as it structures its proteins, right? Because really, when you think about it, when you bodybuild, when you tear down your proteins, you have to restructure that and adapt to that tearing, right? You have to kind of adapt to that. Even your bones do that. So anybody really that's exercising, putting vibration into their body, you should be moving around. The more motion you put in your body, the more electricity you generate. The piezoelectric effect in your bones, you put electricity, grounding yourself outright. I'm probably preaching to the choir here, but the static electric field really does induce that fundamentally, even down to where the binary fission takes over just when the cells start to generate the proteins and structure it fundamentally. And I'm probably ranting way long here. I'm going to go to, there's not a lot of videos on it. It's pretty amazing. Is this one here? It's probably in Dutch or something, but
German secret societies ran into
I just figured I'd do a video.
Nordic-looking beings.
I find this stuff pretty interesting, and it's profound because it blows every theory out of the water of evolution. I mean, you can just start changing life around you yourself. It's kind of funny. Yeah, sorry guys. Let's go back here. So pretty wild to think outside the box on this concept. This is no joke. It's documented. I think the research ended. I'm not sure, what I mean. Knowing this now, anybody can put this stuff together in their basement. You can fundamentally change whatever you want. Go get you a bag of GMO seeds or whatever. I mean, that's what's so cool is you can, if you're changing the phenotype without actually propagating it, right? I mean, this is what's wild. The idea of a male and female in this and getting together, and now you're kicking out different as that goes along, you're still in the static field. But if you've changed that fundamentally for a while, the male and female's eggs and the proteins, right, they structure differently. I wouldn't be surprised if it penetrated into the organisms as the fetus grows into the placenta, just no different than them germinating in the agar plate. You've got a tiny little embryo going down on a human creature, and let's say it's Neanderthal. Let's say it's hominid or whatever, right? And now, after one generation of that thing growing in the static field now that it's presented in, if it's altered quickly, now you got a different thing coming out of the person. It could come out less hairy every time. And let's say even one birth, or every female, they kick out a non-hairy thing out, right? I mean, it would look different. No different than these plants. I'm going to end it here. I can get going long on this because it's pretty wild. And there's not a lot of stuff on it. I'm probably got a comment over here about. Oh, cool. You left me another comment. Sweet, man. Thanks. Anyway, I might even make a comment and do this as a response video to you, Johnny. This stuff's really interesting if you think outside the box. I love your experiments, and keep it up. I had some stuff on my channel, and I just deleted everything. I had a hodgepodge of stuff. I had some, some of the ideas I throw out, I don't know if they've, I don't know. They're pretty off the wall, but this stuff isn't off the wall. I mean, this stuff's provable, you can do the experiment yourself. But what's interesting, too, is, you could swab something on your door handle, right? Grow on an agar plate under a static electric field. It might kill the bacteria. I know some fields can just destroy any kind of bacteria. Electrostatic filters, and they basically just grab it, right? But, you can get things, what happens is you get these tiny, tiny organisms around a static electric field. Let's say you got a static electric generator in your room, and I do believe they used them way, way back in the day to sterilize rooms. You can use static fields to kind of keep things away. But if you got a certain polarity of an object, if it's a bacteria, dust, whatever particle floating around, it can charge it to where it will repel it or accelerate it to the surface. So now if you've got something out here floating around, this tiny, 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 tiny bacteria literally turns into a comet at that state, and it yanks it in, and basically pulverizes any bacteria. Yeah, anyway, pretty cool stuff. If anybody's got a remark out here, I'm already 30 minutes into it. Just throwing out some ideas. I think this is pretty. What I find so cool about it is I think they already got a guy on Thunderbolt's project that's doing the electricity of life. And I wish they would get more into how just the idea. It fundamentally throws off a lot of things of how organisms are structured. And it really starts alluding to why we have so many differences in, obviously, people and how they look. And everybody's kind of got their own electric field, but, you could have electric field change. Let's say if you've got that polar thing going on and you got this tie, and now these people are walking around because they were structured from the prior electric field, but now that electric field's changed, so now they're doing their thing, and now any organism really in that water-filled thing can it can fundamentally change it. And now it might kick at that person to look, totally the same but different. It's wild. Oh, wow. I'm done.